Thanks for being here. Some of you have heard me talking about things for a long time, and some just recently. Welcome. I'll make this concise. I'll talk about why we need to do something, what we need to do, and how we can do it working together. I see two things in this photo: the universe, or part of it, and a telescope. And by the way, you use the telescope to look at the universe. Did you know what a telescope is functionally? It narrows your focus. It excludes a lot from view, It draws your attention to what's brought into view and amplifies it. This is what a telescope is functionally. A drawing is like a telescope. It's a lens for looking at models. It narrows your focus, excluding a lot from view. It draws your attention to what's brought into view and amplifies it. This is what drawing is functionally. You look at models through the lens of drawing. Let me introduce a term. Drawing is an attention-focusing rig, just like a telescope is an attention-focusing rig. And notice this: with your attention focused, then you think about what you see. That's a coupling. Focus drives thinking. The attention-focusing rig elevates our interpretive power and develops our understanding of models, or of the universe if the rig is a telescope. We don't talk about this much these days. All the talk is about models, mostly, and rightfully so. Modeling transformed 30 years ago radically, a colossal shift from mental models to digital models. The impact of this cannot be overstated. It spawned a lot of innovation. Here are some milestones. Remember when these came out? I'm just skimming the surface over 30 years of highlights. There's depth to each of them, so modeling gets the attention it deserves. Attention-focusing rigging, AFR, the lens for looking at models, gets less attention, less development. It gets left at the station, no seat on the innovation train. Look, it looks sad. Can you see that? Oh, so sad. There's been some work on digital drawing, though, mostly automation, starting with BIM since 1987. That long ago. Models drive drawing graphics. Now, very recently, drawing automation is getting an AI front end, like with SWAP. Automation matters, no doubt about it. We've also had fusion. That was my earlier work that I proposed and led at Bentley. We developed automated drawing model fusion and released it in 2012. This fusion is now in software from 9 different software companies that I know of over the last 11 years, including Revisdo. Shout out. Fusion puts drawings where they really are within models. It helps with interpreting. Fusion is really basic, fundamental, like the fusion of sound into silent film 100 years ago. Are these the last stops on the innovation train for drawing, automation, and fusion? Is that enough evolution of the lens for looking, the rigging that engages thought and builds understanding? I don't think so. NASA doesn't think so either. Here's the James Webb Space Telescope. Hubble wasn't enough, so they built this. Notice the evolution in the telescope's form. See the top right of the page, the optical telescope element, which includes the primary mirror, comprised of, I quote, 18 hexagonal segments made of beryllium and coated with gold to capture faint infrared light. That's really something. A better attention-focusing rig, a better lens, to see better, to see further. Should we go further too? Should we go further too? I mean, that's a really dumb question, isn't it? AEC models are very complex, so why would we stop innovating on our lens for looking at them? Why stop? Especially given all the graphics capability supplied by 30+ years of radical innovation in digital modeling. Better equipment for investigating these models only makes sense, because with better AFR equipment, a better lens, we can see, think, communicate, and understand better. We can ask better questions and get better answers, or at least clearer questions and clearer answers. So what would a better lens, a better AFR rig look like? Some caveats first. It has to articulate attentive focus in models and make things clear. It has to correspond with normal human visual perception. It has to be better at making things clear than conventional drawing. It has to be easier to create and use. It has to include conventional drawing, but surpass it too. And it has to be portable, shareable, and open source so that it's widely adoptable across the industry and beyond the industry, by the way. So AFR could take many potential forms, and it will take many forms. Imagine them yourself. I described 20 or so AFR features in the developer specification I wrote and put on my website. You can do the same. Imagine whatever you want in the modeling software you develop or use. I just propose this. AFR development everywhere, in all modeling software, should share 8 open source core features. These 8 features, I believe, are the minimum set of features that A, will make a significant improvement on human attentive focus within models, and B, that correspond with the way human vision actually works. That's derived through features 2 and 3. The rig volume, the rig's scope box, and the built-in camera path for moving back and forth around the scope box in a controlled way. This has to do with the way that beings like us, with eyeballs, we're not worms, actually operate in the world. We engage our visual focus with a bit of back and forth movement around the object of focus. The purpose of this is twofold. 1, contextualizing the object of focus in space in relation to other items. And 2, very important, solving for visual ambiguity. We perform checks against ever-present optical illusion. We miss some, but we disambiguate a lot. The motion helps. We look at things from many angles with continuity. So feature 3 is fundamental, the built-in camera path. It's not optional. If it's not in the software, we're doing it mentally anyway. And think about this in the real world, how it works. And also, think of the development of camera rigging in the history of film. It is significant. And we need to bring this into digital modeling in a controlled way. By the way, watch people engage with digital models. They spend a lot of their time spinning it around. They're doing that motion for a reason. It's innate to visual perception, the way the mind works, cognition. So we need to bring that in and develop better, finer control over that motion as an integral part of our better lens, the better attention focusing rigging that we're going to build. So what would that look like? I mocked it up, and I show that. I'm not going to show it here in this presentation for time. A lot of you have seen the demos before, and if you haven't seen them, please go to tangerinefocus.com and take a look. The videos are on the homepage. Also, there are links to the developer specification and some other articles. They cover the 8 core features and many other potential features. This stuff is not written in stone. It's just, I think, a very good conceptual framework. Plus, it's a significant amount of specification. More than enough to get development started. Well, let's go into the developer perspective briefly. Packaged together, these 8 core features, here they are in the diagram, can be called TGN. TGN is a proposed standardized format for model engagement through a visual attentive focus. TGN is the minimum core feature set intended to solve this problem of the dire need for attentive, focused clarity within models. TGN targets professional grade visual attentive focus, its articulation and communication within models. The TGN feature set can be extended, improved, and tuned, and additional features can be added by anyone. But anyone doing AFR work will benefit from the open source TGN Core feature set, which they can include, build on, and extend. Let's be clear about something that should be obvious. None of these features require new invention. They're not even unique in any way. You probably have all of them in your apps already. What's new is the way they're packaged together to make them actually effective at addressing this critical industry-wide problem: the near total absence of visual, attentive, focused clarity within models. So for developers, here I highlight, for example, 3 of the 8 features. Features 2, 3, and 4. TGN rig volume, TGN camera path, and TGN engagement UI. Look at 2. The white boxes at the top are what you have already in your app. You can define a box. You can use it as a display clipper. You already have that feature. The same is true for 3 and 4. You create a camera, you put it on a path, you transform it between perspective and parallel projection. You have a UI, probably buried somewhere, for rolling the camera back and forth along its path. So what's needed for TGN is you have to code a transformation layer. Write new code to take what you have and transform it to a neutral description. That neutral description needs to sink down and be stored in the TGN rig. The rig is a data package, after all. That way, users can share rigs with others using other modeling apps for other purposes. And sharing is feasible among all apps that implement the TGN code base. There's no magic. They have to implement the TGN code base, and then the neutral descriptions can be retransformed into the language of the target app. So we have to agree on the neutral descriptions, and it's up to each app developer to make the transformation layer work in their app. It has to work in both directions, from the source app to the neutral description, and back again, from the neutral description to your idiosyncratic source app or target app. So after the neutral descriptions and the transform layers are coded, then the features have to be stitched together in a way that makes them operate together. So that's why and what. Now, how are we going to do this? I say, let's divide up the feature development among different software companies. We're asking you, software companies, please volunteer. Please volunteer for the features you want to work on. And we all share the feature code with each other. No one has to do it all. Just do a bit and get the rest. Some of these features can be grouped, by the way, as you can see. If you want to dive into this, the industry will thank you. Together, we can collaborate and decide who wants to do what. So the challenge, code the neutrals and code the transformations. Then together we'll stitch the features together, the red thread. So I conclude now. If these things happen, or I should say, when they happen, then we'll have a code base for TGN, which is to say, the industry will have it, and the industry should have it. And we'll also have a developer community for TGN. And how great is that? With those two things, then what? What's next? TGN is part of an existing open source software foundation? Which one? Who can say? Developers and users, we need you. I hope you all will participate. Let me know if you want to jump into this. You can write me at robsnyder@tangerinefocus.com. And you can find my contact on my website at tangerinefocus.com. Welcome all. Let's build this.